Hi you guys, and welcome back to my YouTube channel. Today we're going to be talking about exponents and how we use exponents. If you like this video, if you find it helpful, please give it a like and be sure to subscribe to my channel to find more videos on different subjects for math and science. So what is an exponent? An exponent is something that tells us how we're going to multiply a function, essentially. So in an exponent, we usually have a base, which we're going to call b, and then we have a power, which we're going to call n for now. You probably see exponents usually written like this, 2 to the power of 3. Now what that tells us is we have 2 times itself 3 times. So 2 times 2 times 2, which would give us 8. So what these two numbers mean is your base is what you're multiplying, and your exponent, or your n, is how many times. We use exponents to condense long problems so that we don't write out 2 times 2 times 2 however many times we have it going for, and it saves you space and makes things more efficient on the page. So let's do some practice. If I have the function 4 to the power of 2, what would that be equal to? That would just be equal to 4 times 4, because we have a base of 4 and we're multiplying it 2 times, which gives us an answer of 16. What if I had 5 to the power of 3? That would be 5 times 5 times 5, which would be 5 times itself 3 times, like the exponent says, which would give us an answer of 125. What if I had 6 to the power of 1? So this one would just be 6, because what this tells us is we have our base, which is 6, and we're multiplying it 1 time. So here we have 6 being multiplied 1 time, which gives us an answer of 6. Now that we've done some practice, let's talk about some other ways that we use exponents. One of the most common ways you're going to see exponents used in your math class is in relation to variables. So something that you might see often is x to the power of 2. X to the power of 2, when you're solving for x, functions pretty much the same way as x to the power of 1. You can only add it to other x to the power of 2 functions. So let's say I have 2x plus 3x squared. I can't add these two numbers together, can I? Because we have x to the first and x to the second. Because they are to a different exponent, that means we can't add them together. So that means this is as simplified as we can make it. But if I had 4x squared plus x minus 2x squared, here we have two monomials with x squared functions. So we can simplify and combine our like terms. So we would do 4x squared minus 2x squared. It's going to give us 2x squared, and then we still have an x left over, so plus x. Let's do some practice with this. If I gave you the function x plus x squared plus 3x minus 4x squared, can you simplify this and combine like terms? So I'm always going to start with my first x, which is, on this case, just a 1x, right? If we don't have a number in front of the x, that means it has a 1 in front of it. So I'm going to look through my numbers and look for another x term. This is not 1, but this is 1, and that's the only other one. So I can add those two together. So that would become 4x. So now that I use those, I'm going to cross them off. Next, I have x squared. So I'm going to look through for another x squared term. I found one here. And I have 1x squared minus 4x squared, which is going to give me 3x squared. So here is our most simplified form. Let's move along and talk about the law of exponents. The law of exponents tells us how we can use exponents in different types of equation solving. So how to use them in relation to addition, subtraction, multiplication, and division. So the first one says that if you are adding or subtracting two numbers with the same base and the same exponent, you'd simply add the constant in front. That's like what we were just doing, right? So if I have 2x squared plus 4x squared, I just add the constant in front. So that would be 6x squared. The next one says that if you are multiplying two terms with the same base and different or the same exponent, then you're going to add the exponents together. So let's say I'm multiplying x cubed times x to the fourth. This would become x to the 3 plus 4. I'm going to add those exponents together and get x to the 7th. Let's try another one like that. Let's say I had 2x squared times 3x to the 4th. What would this simplify into? You start by multiplying the 2 and the 3. 2 times 3 is 6. And then for the x's, we're going to add the exponents. So this would turn into 6x to the 6th. The next law of exponents tells us that when you're dividing two terms with the same base and different exponents, you're going to subtract the exponents. So for instance, let's say I have x to the 7th over x to the 4th. Well, that's the same thing as x times x times x times x times x times x times x over x times x times x times x. So we know that if we have the same thing on the top and the bottom, we're able to cancel them out. So this x is going to cancel out, this one's going to cancel out, this one's going to cancel out, and this one's going to cancel out. So we're left with 3 x's on top, which would give us x cubed. We could also get that by just subtracting 7 minus 4, which would also give us x cubed. So that's the logic behind it. Let's try a couple problems like this. What would you get if I gave you x to the 4th over x to the 2nd? That would just be 4 minus 2, which would be x to the 2nd. What about x to the 9th over x to the 6th? That would also just be 9 minus 6, which would be x to the 3rd. Let's try one that's a little bit harder. What would you get if I had x to the 1st over x to the 3rd? This one's a little different, isn't it? Because we don't have a bigger exponent on top. We're still going to subtract, but that means that our x needs to remain on the bottom because there's more x's on the bottom than the top. If I were to write this out, it would be x over x times x times x. These x's cancel out, and I'm left with 1 over x squared, which is the same thing as 3 minus 1, keeping the 2 on the bottom. Knowing that, try this problem. What do you think the answer here would be? It would be 14 minus 7, keeping the 7 on the bottom, giving us 1 over x to the 7th. The next part of the law of exponents talks about how to use exponents when we're dealing with parentheses. So let's say I have x squared to the power of 5. So that's the same thing as x squared times itself 5 times, right? Let's write that all out. And it would look like this. So in the first law of exponents, we talked about when you're multiplying two numbers with the same base, you add the exponents. So here, those would add to become x to the 4th. Here, they would become x to the 4th. And here, we would keep x to the 2nd. Now we can add these exponents here. We get x to the 8th, and we still have x to the 2nd. So at the end, when you add 8 plus 2, you get x to the 10th. The simpler way that you can do this is you simply take your outside exponent, in this case it's the 5, and you multiply it by the inside exponent. So 2 times 5 is x to the 10th. Let's try some practice with this. Let's say I had x third to the 2nd power. What is that equal to? That would be equal to x to the 6th. What about x to the 8th to the 7th power? That would be equal to x to the power of 56. Try this one. What if I had 2x squared to the power of 3? Now we have a constant in with our x, so that means we have to cube both the constant and the x squared. So 2 to the power of 3 is 8, and x squared to the power of 3 is x to the 6th. We can also do this when we're working with fractions. So let's say I have 1 over x to the power of 3. In a case like this, we can apply these parentheses to both the top and the bottom separately. So this would turn into 1 to the power of 3 over x to the power of 3, which would simplify into 1 over x cubed. Let's try another one like that. Let's say I have y squared over x to the 4th, and this is all to the power of 5. So that's going to simplify into y squared to the power of 5 over x to the 4th to the power of 5. And we know that y squared to the power of 5 is y to the 10th, and x 4th to the power of 5 is x to the 20th. Now we can't do anything to simplify this because we have different bases here, right? We have a y and an x, so we can't subtract to reduce this fraction. Let's try one more like this. So 2x over 3y to the 3rd all power squared. Start by simplifying the top and the bottom. That would become 4x squared over 9y to the 6th. Let's move on to the next part of the law of exponents. The next part is talking about 1 to the power of anything. So we know that 1 times any number is going to be the other number, right? So if I have 1 times 4, that's going to be 4. Or if I have 1 times 256, that's going to be 256. Similarly, if I have 1 to the power of 2, that's just going to be 1 times 1, which is also 1. So anything to the 1 to the power of anything is going to be 1. I could do 1 to the power of 10, that's still 1. I could do 1 to the power of 437, that's still 1. So that's the next one of our exponent rules, that 1 to the power of anything is going to be 1. The last law of exponents that we were going to go over today is when you have a 0 in the exponent. So if I have 2 to the power of 0, that means I have a base of 2 and I'm multiplying it 0 times. Well, since I'm not multiplying it at all, that means the answer is just 1. So anything to the power of 0 is going to be 1, including variables. So just like here, I have x to the power of 0, that's 1. And that's the 0 law of exponents. Let's do some practice using all of the exponent rules that we learned today. Could you simplify this problem? To do this problem, we would multiply x squared times x cubed. They have the same base, so that means we're going to rewrite the base and add the exponents. So the answer to that one would be x to the 5th. What about this one? Can you simplify this problem? So this problem is a trick. Here we have two terms that have different bases. We have an x and a y. So because the bases are different, there's nothing we can do to simplify them. And this just remains x to the 5th over y squared. Try this one. Can you simplify this problem? For this one, we're going to start by putting 2 to the 4th power. 2 to the power of 4 is 16. And for the next part, we multiply the exponent 3 times 4 to give us y to the power of 12. Let's try some more. What would x to the power of 1 times 3x squared be? For this one, we're going to start by multiplying the constants in front of our numbers. So we have 1x to the first, so 1 times 3 is 3. And then we're going to, since we have the same base of the x, we're going to add the exponents, and that would be 3x to the 3rd. How about this one? 2y to the power of 0 times 3x squared. How would you simplify this one? We know that anything to the power of 0 is just 1. So this y to the power of 0 is going to turn into 1. So we're going to have 2 times 1 times 3x squared. So now all we have to do is multiply our constants. So 2 times 1 is 2, times 3 is 6. So our final answer is 6x squared. How about this one? Y to the 16th over y to the 4th. How would you reduce that? Since this is division and we have the same base for both of them, we're simply going to subtract our exponents. So 16 minus 4 is 12, so this would turn into y to the power of 12. And let's do one more problem. Let's do y to the power of 3 over y to the power of 5, all of this squared. So we know that we can apply this square separately to both the top and the bottom. So on top we would get y to the 6th, on the bottom we would get y to the 10th. And now we still have the same base. Both the top and the bottom have a base of 10. Have a base of y. So that means that we can subtract the exponents to simplify this problem. Because y is bigger on the bottom, that means our terms are going to remain on the bottom. So we would do 10 minus 6, and we would get 1 over y to the 4th. This has been Simplifying Exponents and Law of Exponents. If you found this video helpful, please subscribe to my channel. Thank you. Have a good day.